Hey guys, sorry I got interrupted. Okay, so 45% as a decimal, you take the decimal on the very right of the 5 and you move it twice to the left and we get 0.45. Okay? And that 0.45, if we were talking about some sort of shape and which parts were shaded, then instead of having a spinner with 8 pieces, we would have a spinner with 100 pieces, and 45 of them would be shaded. So this 45%, it's kind of like saying 45 out of 100 shapes are shaded. Yeah. So in your homework, it'll probably have you type in the 0.45 and then it'll tell you to pick a phrase that matches this. So you need to pick the phrase that says 45 out of 100, and it's any kind of shapes. I think there's 2 answer choices, one with a rectangle and one with a circle, and both of those you need to choose. So 45% represents 45 out of 100. So it's kind of like I had 100 little squares and only 45% of them were shaded. Yeah, okay. Let's see here. Let's look at the next sucker. It says each individual letter of the word Idaho is placed on a piece of paper, and all 5 pieces of paper that should match how many numbers there are in the word Idaho. Let's check. 1, 2, 3, 4, 5. Okay, so the total amount of letters that we have is the same number for the pieces of paper, 5. Okay, they're placed in a hat. If one letter is selected at random from the hat, find the probability that the letter A is selected. Okay, well, let's see here. How many A's are in Idaho? Well, there's just one. So the probability would be the part over the total, 1 over 5. Or as a decimal, I think it's 0.2. Or as a percentage, it's 20%. Okay, if you're wondering where that 0.2 came from, if you have a calculator, all we did to find this 0.2 was we said 1 old school 4th grade symbol, divide 5, and that should give you that 0.20. Okay, so the probability is 1/5 if they ask for a simplified fraction, 0.2 if they ask for a decimal, or 20 if they ask for a percent. Yeah. Okay, if there was more than one A, then the number on top would change. Like, let's say I have the word ball, and I want to know what's the probability of getting an L. Well, here there's 2 L's out of 4 letters, so the probability would be 2 over 4, or, reduced to 1 over 2, 50%, blah, 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 blah. Okay, so anyway, if there's more than one letter, that's the number you put on the top. I just had one A, so I put one on the top. Okay, let's look at this next sucker. It says mutually exclusive describes 2 events that cannot happen at the same time. For example, giving birth to a child that is both a boy and a girl. In math, we're just going to pretend that's not possible. Technically, there's some fancy techy words to describe this, sciencey words, but we're just going to say, okay, you can't pop out half boy, half girl. Like girl on top, boy on bottom. Yeah, you can't do that. Okay, another thing that cannot happen at the same time is you toss a coin and you land on a head and a tail at the same time. That's mutually exclusive, because when you toss a coin, it either lands with the little head face up, or the coin lands with the tail in like the building, or I don't know what the coin is you have. Okay, so mutually exclusive means the things cannot happen at the same time. Okay, let's look at this example over here on the right. Okay, before we do this example on the right, the answers to these questions are phrases that you have to fill in with like drop down menus. Yeah, okay. So the drop down menus that we're going to use are, we're going to say that the sets are mutually exclusive. So you would choose the drop down menu that says are. And it would say because they cannot both happen at the same time. You might choose the word cannot be both. Okay, then if the sets are not mutually exclusive, you choose the drop down menu that says can be. Okay, so let's remember, mutually exclusive means they cannot happen at the same time. Okay, so part A says a card is even and a card is odd. We know what those mean. And for evens, that's 2, 4, 6, 8. Odds mean 3, 5, 7, 9. Well, I don't have a card that has an odd and an even number at the same time. So this is, since they cannot happen at the same time, that means they are mutually exclusive because they cannot happen at the same time. Those are the words that you're going to choose in your drop-down menu. Yeah. Okay, let's look at B. It says the card is an even number and the card is a composite number. Okay, an even number could be like 2, and a composite number could be 8. Even is 2. Composite means that something else besides itself and one can divide into it. So, can we have a card that says 2 and 8? No, we can't. But can we have a card that has a number on it that's already even and is composite? And that's true. We could just have like the number 8, just the number 8. Because if you look at the number 8, it's even and it's composite because 4 can divide into it, 2 can divide into it. Yeah. So these can happen at the same time. So when they can happen at the same time, they are not mutually exclusive. So you're going to choose the option that says are not mutually exclusive. And they are not because they can happen at the same time. Okay, let's look again. The next sucker says black and a club. So let's think about that. Can it happen at the same time? Here are the clubs, and oh gatos, they are black. So that can happen at the same time. The black and the club. So what word do I use for can? I say they are not mutually exclusive. Okay, let's look at the next one. The card is a face and a red number. Well, let's see here. Here are the faces, and I don't see any numbers. I see red, but I don't see numbers. So these cannot happen at the same time. The face, card, and a red number. So since they cannot happen at the same time, we're going to choose they are mutually exclusive. Okay, next sucker, a spade, and the card is a face card. Well, let's see what a spade is. A spade are these like upside down heart things. Okay, and a face is, look right there, we can have face cards with those little spades. So that means it can happen. And since they can happen, they are not mutually exclusive. Okay, last sucker. We got a spade and a diamond. So let's see here. Do spades and diamonds exist on the same card? And they don't. They're two totally different cards. So those cannot happen at the same time. So cannot means they are, woohoo! So it's all about whether they can exist at the same time. Okay, let's look at this next sucker. This one really threw me. It said a bag contains in cards. What? What? So that means the total is in. What? Yeah, that's weird. Okay. It says, if all numbers are used, the probability of drawing a card with a number less than or equal to 4. What are numbers less than or equal to 4? Well, 4, because equal. Then 3, 2, 1. And then we don't put 0 because 0 was not in that list of numbers that they gave us. Yeah, so just 4, 3, 2, 1. Okay, and it says that probability is 1 over 6. And then it says how many cards are in the bag. What? Okay, so when it says how many cards are in the bag, that's another way of saying what's the total amount of cards. And if we were talking about a regular deck, it would be 52, but we're not sure about this guy. Okay, so I do know that the probability is 1 over 6. And that represents the part over the total. Okay? They gave us that the total is the letter N, because there's a bag containing N cards. So the total is the letter N. And then the part is however many cards we were talking about out of that bag. So let's look at the cards we were talking about out of that bag. We were talking about the cards that are less than or equal to 4. And there's 4 there. 4 numbers that I just wrote down. And that's going to be for the part. So it's like we're going bass-ackwards. It's like they gave us the reduced fraction, like the aftermath, and we have to figure out what we started with. So it's kind of like they gave us the 2 over 3, and we have to go bass-ackwards to find the original numbers. Okay, well, let's think about this. To get from 8 over 12 to 2 over 3, we divided by 4. But now we're going backwards. So let's look at our numbers. I need to figure out, what do I multiply this 1 on the top by to get this 4? Well, let's see. 1 times who equals 4? What do you have to multiply? Well, you have to multiply by 4. Because 1 times 4 is this 4. I sneezed. Woo! Okay, so now let's do the same pattern. They want to know what N is. So let's say, okay, 6, that's already there, times whatever we had to multiply by to get this 4, which is 4, is 24. And that's what N is. So this is saying that there are 24 cards in the bag. And then there were 4 cards that were less than or equal to 4. And 4 over 24 reduces to 1 over 6. Yay!